Okay. Let's get rolling then here. Okay, so let's zoom in here on our first couple questions. Okay. We've got directions here. It says answer each question for the following functions, right? So here's our function f of x. It's equal to -1/2 x squared plus 2. Okay. Letter A asks, does this function open up or down? Down. What? What is negative? -1/2, or in other words, the a value there. Okay. So a equals -1/2. Okay. Okay, so it was down. How else could we check that? What else could we have done here besides just knowing that? How could we have used our graphing calculators to check that? Graph it, right? Just graph it. Go to y equals. Let me clear this stuff out here, and type it in. In parentheses, your fraction. Okay. Whoops. Oh well, that's fine. X squared plus 2. Okay, and then graph it. And then it's very obvious. Bless you. Yes. Okay. Bless you. Okay. What is the axis of symmetry for this function? It is not -1/2. So that's where the vertex is. The vertex is at 0, 2. So we can answer that right here. Okay. Remember, the vertex is the peak or the maximum minimum of the function. So that's going to be 0, 2 here. Very good. Okay. But the axis of symmetry. Now the axis of symmetry, it goes through the vertex. Right. The axis of symmetry is a line that goes through the vertex here. Okay. And it's a vertical line. Yeah, it's just x equals 0. Exactly right. X equals 0. Okay? Notice here we got a formula. Now, I'm not going to give you this on tomorrow's test. You need to know this. Remember that the formula for the axis of symmetry is x equals -b over 2a. Right? So you can literally plug in b. What is our b value up here? It's going to be 0. What's our a value from up here? -1/2. Okay, but 0 divided by anything is going to be 0. So there, it's just x equals 0 there. Okay, from that calculation right there. Okay. All right, now, what is the vertex of this function? Well, again, the vertex is going to be the same x value as the axis of symmetry. Or you can use that -b over 2a calculation as well, because again, that's also from the axis of symmetry there. You can plug 0 in, so 0 squared. One second. 0 squared. What's 0 times 0? 0 times -1/2. 0 again, plus 2. 2. And so there's where you get the y value of 2. Again, we took that 0, plugged it into the function, and we got 2 for the y value. Okay, Aaron, what was your question? Sorry.
Do we have to use that formula?
No. If you can graph it, Aaron, and find your vertex that way, absolutely. In fact, let's take a look, right? Let's say, for example, though, Aaron graphed his, and he wasn't sure that it was at 0, 2. I mean, he's pretty sure it's at 0, 2. How can we check for sure that that is the maximum point there? What do we do on our calculator? Second trace. Which command? Look at where the vertex is located. Where is the vertex located? It's located at the top, right? So which command do we want to use here to find the top? Maximum. Yeah, go to maximum. Okay, hit enter, go to the left, for left bound, hit enter, go to the right, hit enter, and then go in for the top, hit enter. And there. Aaron was right, okay? But now we know for sure the calculator gave it to us. Okay? Remember that you can use your calculator for the whole thing tomorrow, okay? There's not going to be a place where I'm like, you can't use your calculator here, okay? You will be able to use your calculator for everything. All right? Questions so far? Alyssa, do you need a graphing calculator? Okay. Just checking to make sure. Sorry. All right. And you're okay with all these commands and stuff I've been going through? Yeah. All right. Just making sure. Because, again, we want to be very comfortable with this. All right. Caitlin, I know you just got one. Are you comfortable with all this kind of stuff, too? All right. Moving on, then. Next, it says create a table of values to find other points on the parabola. Then we're going to graph the function. Okay? Remember, we put the vertex in the center of our table. So I'm going to put it 0, and then, well, it has us do the calculations here, 2. Okay? So we pick x values to the left of 0, so like -1 and -2, and we'll pick some x values to the right of 0, so like what should go in here? 1, 2. Okay, how can we find their matching y values? Plug them into the function. Okay, so like literally you can just do f of -2 here, which is going to be -1/2 parentheses -2 squared plus 2. So I'll literally just plug -2 in for x. Okay, -2 squared is 4 times -1/2 is -2 plus 2 is going to be 0. So I have the ordered pair -2, 0. Okay, that's a lot of work for me to have to evaluate this function at every single point. What else could I do here? Use the calculator. And I'm going to check where. Where in the calculator can we fill this table in? Or where does the calculator tell us how to fill a table in? Second graph to the table menu there, right? Okay. I got -2 is 0. -1 is 1.5. Okay. I already have 0, 2. 1 is 1.5. 2 is 0. Okay, just like that. All right, now we're going to plot these points. All right, we're going to plot the points. So we've got -2, 0, -1, 1.5, 0, 2, 1, 1.5, and then 2, 0. Okay. Do I need to find any more points than that? No. No. If you want to, you can. You've got your table right here. Just pick some more points. But I'm good with that. So we're just going to kind of connect those dots. Make sure you put arrows at the end, please, to show that it keeps going. Okay. Okay. And we want to answer some characteristics down here. Okay. What's the y-intercept of this graph? The y-intercept is where the graph does what? Not always. Why is it 2 though? Why? I mean, in this case, you are right, Trey. It does work out to be this case. But it's where the graph crosses the what? For the y-intercept, where it crosses the y-axis. Okay, so the vertex in this case, Trey, happens to be that same point. So it's the point 0, 2. So now you know though, y-intercept. What's an x-intercept? It's where the graph crosses the x-axis, which is synonymous as what other term down here? What are these other terms also means x-intercept? Which one of these terms here also means x-intercept? Range describes the domain describes the what? Yeah, domain describes x values. Range describes y values. So what is a synonym for x-intercepts? It's the zeros. Zeros, where the graph crosses the x-axis. Okay? Also, roots is another phrase sometimes used there. I know we talk about square roots and roots, but they're not quite the same thing. Okay? So, let's talk about the zeros here. What are the zeros of this function? -2, 0, and 2, 0. If you also just say -2 and 2, that's okay as well. But I'm going to list both the coordinates there. Okay. Alrighty. What about the domain here? Domain describes what again? X values. And x's are left to right, right? What's the farthest left this graph goes? -infinity. What's the farthest right this graph goes? Infinity. Okay. What about the range? Range describes the top and the bottom. So we're going to go bottom to top, though. What is the bottommost point here? It looks like it's going to be. What's the farthest down we're going to go? -infinity. Very good, guys. Yeah. Okay. Up to, what's the highest y value we're going to hit? 2. Okay. And we actually get there, right? That's an actual point. So we're going to put square brackets. It's an actual point on our graph. So square bracket there. All right. Questions on the front page. Alyssa, you feeling all right? Okay, just making sure. Put your head down. I want to make sure you're feeling all right. All right, next. Turn the page. All right, more graphing. Now, this is in a different form, okay? This first form here, this was in standard form. Okay, if you care about naming it right there, it's good to know. Okay? This form right here, whoops, I can't show it. There we go. This is in the zeros form. Okay? So, looking at this, does this function open up or down? Up. Okay. I hear up. Anyone else want to say up or down?
Down.
You change your mind to down? Okay. Why down? What about this? It is down. What about this indicates it opens downward? The A is negative. Yep, this -2, that's also the A here, folks. It's also the A, right? Imagine foiling, if you don't believe me, imagine foiling this out, right? We're going to have x times x, but then it's going to be multiplied by -2, so it's going to be -2x squared. So down, again, so A is less than 0, or you could say A equals -2 there. Okay, I'll put that in parentheses. Either one you want to say is fine. What are the roots? Okay, the roots. In other words, where does this thing cross the x-axis? Close. It's the opposite of those.
Oh, yeah.
So it's going to be x equals 2 and x equals -1. Okay? So these are the zeros right here. Okay, right? We can take this and set it equal to 0 to find the zeros. Okay, you can take it, set it equal to 0 to find the zeros. We can then set each one of these two things equal to 0. We have x minus 2 equals 0. We have x plus 1 equals 0. And so we'll add 2. We get x equals 2. And then subtract 1. Get x equals -1. So there are your zeros right there. Okay. How else can we find the zeros for this function without doing what I did right here? What other options do we have? What other options do we have? We could graph this in our graphing calculator and then find the zeros that way too. Okay? But really it's just you set equal to 0. Set equal to 0 and solve. And then set each factor equal to 0 using the zero product property. Okay? What's the axis of symmetry? Okay? So again, there's a couple options we have here. Can we use this formula here to find the axis of symmetry? Can we use this formula here to find the axis of symmetry? In our case over here. Can we use it? Ooh, no one's sure. So, can we use this formula? Remember, this is the formula x equals -b over 2a. That's what we use to find the axis of symmetry on the front page for this. Okay? Can we use that -b over 2a formula here to get the axis of symmetry?
Sure.
Okay, sure. We can, but we have to know what b and a are, right? What's a in this problem?
-2.
We know it's -2. What's the b in this problem, though?
0. No,
We don't know yet. We have to multiply this out. So you'd have to FOIL this out and then multiply the 2 through in order to find out what your b is. Okay? So you could do it. You could do -b over 2a, but it's also not quite set up in the right form to use -b over 2a just yet. Well, how else could we do it? Remember, the axis of symmetry is exactly halfway between your two zeros. Okay? Your axis of symmetry, right? These two zeros are going to be, well, I'll just plot them right down here. We got a 2. We got -1 right there. All right, there are my two zeros. So where does my line of symmetry have to go? Through what value? Ugh, that's annoying. Is x equals 1? Is that through the middle? What's exactly in the middle between -1 and 2? 0.5. Yeah, it's going to be a half, which is kind of stinks. Okay, how do we find it? Well, it also tells us here, halfway between the two roots, add them and divide by 2. Right, so in other words, we can take our two roots, 2 plus -1, and divide by 2. So 2 plus -1 is 1 over 2, so it's 1/2. Okay, so x equals 1/2 is what you get there. Okay? That's your axis of symmetry. Hey, now that we know the axis of symmetry, what do we know is the x-coordinate for our vertex? If the axis of symmetry is x equals 1/2, what will the x-coordinate for the vertex be? 1/2 as well, right? It has to be the same x-coordinate. Okay? Now that I know that x-coordinate, how can we find the matching y-coordinate for the vertex? What can we do? I have the x-coordinate for the vertex of this function. How can I find the matching y-coordinate? What can I do? plug the 1/2 in for the x values there, right? Plug them in for the x values, okay? So I'm just going to find f of 1/2, okay, which is going to be -2 times 1/2 minus 2 times 1/2 plus 1, okay? And then we can just type that into our calculator because I don't want to have to deal with the fractions and stuff if I don't have to. Okay, -2 parentheses 1/2 minus 2, 1/2 plus 1. Okay, and I get 4.5 when I do all that work there. Okay. Did I have to do all these calculations to find the axis of symmetry, to find the vertex? Did I have to do all these calculations? No. What else could I have done? What else could I have done? Could have just graphed this. Folks, you can type this, literally type this into your graphing calculator. Watch. -2, bless you, parentheses x minus 2, parentheses x plus 1. Okay, graph it. Do you see your 0 at -1? Oh, sorry. Do you see the 0 there at -1? Do you see the other 0 at 1, 2? Okay, so -1 and 2, right? To find the vertex, what command would I use here to find the vertex? Second trace, and then down to what? Maximum, because the vertex is at the maximum. Go to the left of your vertex, hit enter. Go to the right of your vertex, hit enter. Go in towards the top and hit enter. And do you see it? That's rounding. That's a rounding error, so throw it out. It's 0.5 comma 4.5, and that is exactly what we came up with. Okay? Once you have that, you can then say, oh, then the axis of symmetry is x equals 0.5, right? The x coordinate of the vertex and the axis of symmetry are the same x value. Okay? All right, let's plug it in here. 1/2 and 4.5. All right, I'm going to pick some nicer numbers to the left, so I'll do 0 and then like -1. I'll do like 1 and then 2. Okay, so I'm going to pick non-fraction values there. Okay. Now, we already know what the y value at -1 is. What's the y value at -1? I already have them graphed. What's the y value at -1? 0. It gives it to us, right? We already had that 0. What's the y value at 2? 0. Okay. Now I'll just plug in 0. I'm going to go to my table to help me fill that out. So second graph. At 0 we get 4, and at 1 we get 4. Okay. So there are some points. And let's just plot them. 0, 4, 1, 4, and then 1/2, 4.5. So like right there. And we'll just connect the dots. Okay, if you want to get more points, you can. Okay. Questions on any of that? Yes. Yes. Okay. I didn't run all the ordered pairs, but you guys get the idea. All right. What is the domain? -infinity to infinity. And the range? -infinity to not just 4, what was the highest y value? 4.5 is the y value there. Okay, so there's our domain and range. Okay, questions on any of those? All right, let's keep it moving here then. Okay. All right, now we're going to simplify some square roots. So let's zoom in here on number 3. Okay. What? That's all right. You can cross out this part. This is not an equation, so we don't have to worry about positive and negative solutions. Okay, you can cross that part out. These are not equations, so you can cross that part out. Okay, only when you have an equation, like number 7, that's where you want to be careful about the positive and negative solutions. You can cross that part out. Okay, all we're trying to do here is just simplify. All right, so let's zoom in here. Okay, yes. When, who's out? Braden's out. When Braden comes back, here we go. Okay. All right. Now, Am I going to give you the perfect squares on your test tomorrow? No, I'm not. But how can you come up with the perfect squares? Just do them in your calculator. I mean, you can just like do, okay, 1 squared is 1. 2 squared is 4. 3 squared is 9. And then you get, 4 squared is 16, then 25, then 36, then 49, then 64, 81, 100, 121, 144, okay? You can just like literally just type them into your calculator, okay? And you can figure out what the perfect squares are. Write them out for yourself so you can refer back to them, okay? This is 4 squared, 5 squared, 6 squared, 7, 8, 9, 10, 11, and 12 squared. You shouldn't have to go any higher than those, I don't think. Okay? So let's look at the square root of 48. Is the square root of 48 a perfect square? No. But it's between 36 and 49. So we'll start guessing by dividing by 36, then 25, then 16, and so on and so forth. Okay? So let's see here. Let's try, let's see, can I fit everything on there that I want to? Yes. Okay, so let's do 48 divided by 36. Doesn't work, right? Not what we want. 48 divided by 25. Doesn't work. Not what we want there, right? Okay, see that decimal there? Let's try 48 divided by 16. Does that one work? Is that a good one? Yes. Okay, so square root of 48 is equal to the square root of 16 times the square root of 3.
So we're done right there?
Are we done? Good question. Are we done here, folks? What can I still do here?
Something with the 16, man.
What is the square root of 16? 4. Okay, so we get 4 times the square root of 3.
No, we're done.
That's finished, right? Because can we divide 3 by any more perfect squares? No. Aaron, that phone's not going to be able to help you tomorrow. Okay? Yes. Okay. All right, let's try 242. Okay? Oh, thank you. Okay, yeah, 242 is pretty big. All right, let's see here. 242... let me keep going here. So 13 squared is 169. 14 squared, 196. 15 squared, I know, is 225. Okay. So let's see. 242 is 242. Oh, I got to go one more here. 16 squared is 256. Okay. Is 242 a perfect square? No. Okay, so we're going to divide by perfect squares. Let's see, it's between 15 squared and 16 squared, so let's divide by 225. Nope. All right, 242 divided by 196. No, still not. All right, let's try 242 divided by 169. Nope. 242 divided by 144. Whoops. Nope. 242 divided by 121. What do you guys think? 0. Yes. Okay, so the square root of 242 is equal to the square root of 121 times the square root of 2. Okay. What is, let's see if I can show it to you. Yep. What is the square root of 121? 11, right here. So we get 11 times the square root of 2. Can we break down 2 anymore? No, we're done. Okay, we're done. 11 times the square root of 2. Notice the square root symbol goes away. We took the square root of 121. It's 11, so we don't need to rewrite it. We don't need to write the square root anymore. Okay. So far, so good. Any questions so far? Okay. All right, let's try another one here. 7 times the square root of 54. All right. So, Alessandro, is square root of 54 a perfect square? No, it's not. So what do we want to start dividing by? Where should we start dividing? By what perfect square should we check? It's between 49 and 64. Okay, so we'll start with the 49 then. Okay, and see. So 54 divided by 49? No. And guys, you might look at that and you know what, Mr. Wood, I already know that 54 will not be divisible by 49. And you can skip it if you want to. We'll just go down to the next one, 36. Close, but that's not even. Okay. 54 divided by 25. Is 54 going to be divisible by 25? No, right? It's not going to work. You guys know that maybe already, right? So 54 divided by 16? It still didn't work. Okay, let's try 54 divided by 9. There we go. So 54 then, we still have the 7, so it's going to be a 7, still from what's in front, then square root of 9 times the square root of what? 7 times root 9 times root 6. Okay? What's the square root of 9? 3. So it's 7 times 3 times the square root of 6. Okay? And what's 7 times 3? 21. 21 square roots of 6. Okay? All right. Let's go to Aaron. Aaron, is 200 a perfect square? No, it's not. Can you think of any perfect squares that do divide 200? Look at our list down here. 100 does. Yeah, let's do 100. What is, so it's going to be 3 square root of 100, square root of, what's this number going to be right here? Sorry, what? What's this number going to be right here? So, oh, I'm sorry, you can't see it. Sorry. This number right here. So 200, we broke it down to 100 and what multiplies with that 100 to give us the 2? 2. Yeah. Okay, that's how we break it down. And so then we have 3, the square root of 100 now, Aaron, sorry, is, what's the square root of 100? Not 10 squared. The square root of 100 is just 10. Okay? Yes, a 100 is 10 squared, Aaron, you're right. But then when we square root the 100, it's just plain old 10. Okay, and we have the root 2. Aaron, can we divide root 2 by any more perfect squares besides 1? Nope, so we're done. It's 30 square root of 2. And there's our answer. Okay? Questions on any of that? That's simplest radical form. We first check to see if it is a perfect square, and if it is a perfect square, we know we're done. If it's not a perfect square, then we need to see if we can divide that number by any perfect squares. Okay? And then simplify. Okay? All right. Alex, John, you guys doing okay back there?
Yeah.
All right. Lily, Hannah T, Sky, Anna, y'all doing okay back there? Yeah. Okay. All right, let's keep it rolling here then, folks. Number 7. So number 7 says find the solution set for the following equations, or equations. The easiest way to do it is to isolate the squared part on the left and then take the square root of both sides. Remember that numbers have positive and negative square roots. Okay, so number 7. Jasmine, what should we do here to solve this? Square root both sides, exactly. Okay, x equals, what's the square root of 25, Jasmine? 5. But since we're in an equation, our final answer should be x equals, yes, the plus or minus. Very good. Okay, plus or minus. All right, great. All right, Caitlin, how about number 8 there, Caitlin? What can we do here to start to solve that equation? What would you want to divide by? So it's x minus 3. So we wouldn't want to divide by 3. We would want to what? Okay. And we are going to add 3 eventually. But that minus 3 is inside of a square. Right? So we need to get rid of that square first. How do you get rid of the square? Square root both sides. You got it. Okay, so now when I square root the square, what's going to be left over here, Caitlin, on this left-hand side? Very good. And then over here, square root of 121, is the square root of 121 a perfect square? Or is 121 a perfect square? Is 121 a perfect square? Yes. What is it? 11. So this will be plus or minus 11 there, right? Okay? All right, very good. And then final step there, Caitlin, what should we do? Add 3 to both sides. You got it. We get x equals 3 plus or minus 11. Which means, folks, right, there's only 2 solutions, right? It's x equals 3 plus 11. It's x equals 3 minus 11. Okay? 3 plus 11 is 14. 3 minus 11 is negative 8. So those are really two final solutions. Okay, 14 and negative 8. Don't believe me? Plug them back in. 14 minus 3, square it, you get 121. Negative 8 minus 3, square that answer, you get 121. You can plug them back into your calculator to check. All right. Let's take a look at another one here. Number 9. All right. Cameron, number 9. What should be my first step here, you think? Yes, good thought. Add 9 to both sides. We get 80. Then what? Cameron, go ahead. Yes. Okay, Caitlin, you can see the difference here. The square is only with the x. And so we can get rid of that minus 9. We can divide both sides by 5, like we're doing here, and then we'll just have x squared. Whereas here, the minus 3 was inside being squared too. That's why we had to get rid of the square first there. See the difference? Okay. So we get x squared equals 16. Very good. Cameron, finish it off for us. What do we do?
Wouldn't the square root of 16 just be...
Yes. So, but because we're in an equation, it should be x equals plus or minus 4. Okay, so there are your two solutions. Okay? Questions on any of that? Getting the hang of it? Good. All right. Kaylee feeling all right? I mean, besides this being boring as, heck. Alyssa, you doing all right too? Besides this being boring as heck? Okay. Lexi, you doing all right? Besides this being boring as heck? Oh, she's smiling. Yeah, she knows I'm right. Unfortunately, she knows I'm right. I know I'm right. Okay. Let's keep going here. All right. Wow, that's a lot of reading.
Please tell the test
Let me wet myself.
If it is, I'm sorry.
The test will not be like that. This will not be like that. This is for our own benefit. All right? The parent function for a quadratic formula or quadratic function, f of x equals x squared, okay, is this parabola right here. This is the parent function, and we can transform it, right? Remember, if numbers are added, subtracted, or multiplied, it transforms the parabolas in the following way. Okay, remember when we put a plus h in with the x? That was a horizontal shift, okay? If h was negative, so we're adding a negative number, that means we moved it to the left. If h was a positive, if h was a negative number, we moved it to the right. Oh, that's kind of a confusing way. They should put a minus h in there. Anyway, so let me just write it this way. Okay, let me just put it this way. I don't think they put it in a very good way. Okay. The idea is the number, if you are adding or subtracting inside with the x, it's the opposite. So the number in the parentheses is the opposite of what you'd expect. A minus 3 means you go right 3. A plus 2 means you go left 2. Okay. Now, all that being said, a number on the outside, plus k on the outside, that's a vertical shift, which means we're going which directions? For a vertical shift, we're going to go which directions? How does a vertical shift affect the graph? It moves it vertical, up and down, up and down. That's right. So this plus k, and it goes exactly how you'd expect. So x squared plus 3, up 3. X squared minus 4, down 4. Okay, just as an example right there. And then finally an A in front, and that is the same A from standard form. Okay? You guys already know. If A is negative, what does that A do? If A is negative, what does that A do to the graph? Instead of being concave up, it's going to be concave down, like a frown. Okay? That's right. So that's a reflection over the x-axis. Okay? I'll put that down here. A less than 0, reflect over x-axis. Okay? If A is bigger than 1, okay, it's a stretch. If A is between 0 and 1, that's a shrink. Okay? Now, 10, 11, and 12, the directions ask us to use the information from above to graph each of the following functions. So you can use the transformations. Okay? Now, it asks us to use the transformations to graph it. But what if we get to the test tomorrow and we're like, oh, I kind of remember my transformations, but I kind of am forgetting them now because I'm kind of freaking out. What can we do instead? What do we have available to us to help us graph this? Graphing calculator. That's right. You can use that. But let's go ahead and just use our transformations for right now. Number 10. Okay. Frank, what kind of transformations do you see here at number 10? What's this plus 2 going to do? Left 2 and the minus 3? It is what you expect. Right. So this is going to be left 2, down 3. Okay, left 2, down 3. So normally we start at 0, 0. We're going to go left 1, 2, and down 1, 2, 3. There's our new vertex. Okay, and then once you have that shift, you can create a little table. Okay, I'll put the vertex in the center there at negative 2, negative 3. And I'll pick some x values before negative 2. And I'll pick some x values after negative 2. Okay, and we'll find the matching y values. Okay. Your choice. You can do this by hand by plugging the negative 4 and negative 3, the negative 1 and 0 in and finding the matching y values, or we'll go to our table. Oops, I got to change my function here. Okay, and let's see here. At negative 4, I get 1. At negative 3, I get negative 2. At negative 1, I get negative 2. And then at 0, I get 1. Okay, so we'll plot those points. Negative 4, 1. Negative 3, negative 2. Negative 1, negative 2. 0, 1. Okay, and then connect the dots. Okay? Easy peasy, right? Lemon squeezy. Right? You ready to move on yet? Let's see if he feels so right now. Hang on. What's that, Braden?
We can take like a 5-minute break.
5-minute break? No. Bad idea.
Sleepy.
Bad idea.
Yeah, take a 5-minute nap.
5-minute nap? Psh.
Yeah. Good idea.
More like 5-hour nap. Yeah. If you take a 5-hour nap, you'll be here, and then we have to lock you in.
You wake up and feel like you're dead.
Mm-hmm. That's a little too much sleep, I think, or too much napping at least. All right, let's do the next one. Next one, what kind of transformations do we see here? I see a -1 on the outside. That means we're going to shift down 1. Are we going to shift left or right at all? No, there's no numbers inside with the x, right? So we're not going to shift left or right. We're just going to go down 1. So from our normal vertex at 0, 0, we just go down 1. There's our new vertex. Okay, so to make our table, okay, we're going to put that, we'll put that 0, -1 right in the middle of the table. Pick some x values before, pick some x values after. Okay. And then again, we can go to our, you can plug them in, or we can just go to our table and our graphing calculator after you type it in. Okay. And I get -2, 7. -1, 1. 1, 1. And 2, 7. Okay, you can see them right there on the table. And just plot the points. -1, 1. 1, 1. -2, 7. Oh, I can't fit that one. Doggone it. Well, I'm just going to kind of eyeball it there because I do want to kind of have 5 points. Okay. Can you kind of see the stretch there? Right, that 2, remember that 2, that stretches it vertically. Do you see how it's more stretched out? It's a little more squished in. Okay, do you see that? All right. And then number 12. Okay. What kind of transformations do we see here for number 12? Not left. Careful. The number in with the x is the opposite of what you'd expect. So you said left one, but you really should have said right one. Now the +2 on the outside, that is what you'd expect, so we're going to go which direction for that? The +2 on the outside, folks, what does that tell us to do? Up. How much? 2. So again, from the origin, right 1, up 2. There's your new vertex. Make a little chart. Okay. 1, 2. Okay. So I'll pick 0 and -1 there, and then 2 and 3 here. And then I'm going to go to my table. That -1/2, okay, what's the negative going to do? Instead of concave up, it will be what? Concave down, because it's -a value, okay? And it's also going to be 1/2, so that's actually going to squish it. It's going to shrink it vertically. Okay, so I type this in my calculator. Oh, I don't need to graph it. Second graph, I mean. All right, so I get -1, 0, 0, 1.5, 1, 2, 2, 1.5, and then 3, 0. Okay, so just plot those points. -1, 0, 0, 1.5, 1, 2, 2, 1.5, and then 3, 0. Okay. Can you see the squish? Can you see how it's squished? How the 1/2 is kind of squishing it, right? It's a little more wide than we're used to there. Okay, it's a little more wide. Okay, questions on any of that? All right. Let's take a look here at the next one. So, all of this focus was on graphing, right? So we had front page, back of the front page. Well, I guess this was not all graphing. That was simplifying square roots and solving square root equations. But more graphing here, okay? So again, the two big kind of things we need to be able to do: graph quadratics, solve quadratic equations, okay? How can we solve quadratic equations? Well, we use like the square roots, right? We simplify those square roots too sometimes. Sometimes we also factor. Okay? So, for example, right, here we're looking at this problem right here where they factored, right? X squared minus 7x plus 10. You take your lead coefficient of 1, multiply it back to the 10 there. Okay, you get 10. Two numbers that multiply to 10 but add to -7, -5 and -2. Okay, so they factored it and then said each factor equal to 0 and solved. Oop, that's not right. That should be x minus 5 equals 0, x minus 2 equals 0, and that should be then +5 and +2 there. Okay, because you're going to add to both sides. Okay, they made a little error there in their calculations. Okay. Okay. So, let's go ahead and take a look at these by factoring. Let's solve these by factoring. Okay, so first of all, is this in standard form? Close. It's got the x squared, but what needs to go next? Not the -24. What needs to go next there, Kaylee? For it to be in the right order. The 10x. And then the -24, and then it's equal to 0. Okay, so now it's in standard form. Okay, we're going to factor this. So again, I'm going to take my lead coefficient 1, multiply it with a -24. I need two numbers that multiply to -24 but add to make +10. Two numbers that multiply negative 24 but add to make positive 10. What do we say here, folks? 6 and 4? 2 and 12? Which one is it? Which one do you want to use? Let's try 6 and 4. You mean 6 and like negative 4, I guess, right, Kaylee? Because we need to multiply negative 24. Do they add to make 10? They don't, do they? How about negative 6 and positive 4? Well, we can't use negative 6 and negative 4 because they multiply to positive 24 then, if I have negative 6 and negative 4. Okay, what do they add to make, Kaylee? Negative 2, we need 10. Trey, what'd you say?
12 and 2.
Negative 12 and positive 2? Well, they add to make negative 10. You're close. What else can we try? Yeah, positive 2, negative, oh shoot, negative 2, positive 12. They add to make 10. Okay, so x squared plus 12x minus 2x minus 24 equals 0. So break up that middle term using the two numbers that Trey found for us. Group the first two, group the second two. What can we take out from the first group? An x. And we're left with an x plus 12. What can I take out from the second group? A negative 2. If I take a negative 2 out of this, I'm left with an x. Take a negative 2 out of negative 24, it's positive 12. Hey. So we can take out that x plus 12, and I'm left with an x minus 2. Okay. I factored it. Are we done? What do I have to do now with my two factors? Set them equal to 0. So x plus 12 equals 0, x minus 2 equals 0. And now, Trey, we'll subtract the 12 from both sides. X equals negative 12. Ooh, I'm out of space there. And add to x equals 2. So what are my two solutions? Negative 12, positive 2. Or you can just say x equals negative 12, x equals 2. Your choice there. Sorry?
Do your hand hurt from the right?
Nah. I have built strong hand muscles from all of writing that I do. Okay? Questions on that? Let's keep going. Yeah. We got to make hay while the sun is shining, folks. Okay?
The sun was shining in.
It will, but we might not have time to make the hay at that point. Right now, the sun is shining. We're going to make hay. Okay? Okay. Is this in standard form? No. What do I need to do here to get this in standard form? So that's a way to solve it. We're going to solve this one by factoring. So yes, you could, Kaylee, divide both sides by 6 and then square root. That would work. But we're going to solve this one by factoring. So we need to be in standard form here. What do I need to do here to get this in the right form for factoring? That's for solving by using square roots. We would get the x squared by itself that way. But I don't want it. Remember, look over here, right? This was standard form. It was equal to 0, right? And it was x squared, then x, then our number. Is this equal to 0 yet? No. What do I have to do to make it equal to 0? Subtract 150 from both sides here. Okay, then I'll get 6x squared minus 150 equals 0. Okay? Now this one's a little bit different, isn't it? It's a little bit different. Okay? There's actually a GCF. If you see here, there's a little note. Okay? There's a GCF. There's a greatest common factor that we can factor out first before we factor this quadratic. Okay? What can I take out of these two terms right away, right off the bat? Okay? Both of these are divisible by 6. I can take a 6 out. If I take 6 out of this, I'm left with x squared minus, and then 150 divided by 6 is 25. Okay? Now I'm going to try and factor this thing. X squared minus 25. Okay? I'm going to do 1 times negative 25. I get negative 25. Right? The 1 in front here times negative 25. Okay? I need two numbers that multiply negative 25 and add to my middle term. What is my middle term here? It's a 0. That's right. So then what two numbers multiply negative 25 but add to make 0? 5 and negative 5. That's right. Good job, Trey. Okay. So this becomes x squared minus 5x plus 5x minus 25. Okay, I'll zoom in some more here for you guys. Okay, from this first group, what can we take out of this first group here? An x. What can we take out of the second group right here? A 5. And they both have an x minus 5 in common, so we're going to end up with 6 times x minus 5 times x plus 5. So set them both equal to 0. I'm going to run out of space. I'll do it up here. Okay. You could set 6 equal to 0, but does 6 ever equal 0? No, so we're not going to worry about that one. Just the ones with the x's. We'll add 5 to both sides. X equals 5. Subtract 5 from both sides. X equals negative 5. We got our answers there. Oh! We're not done yet. Request you guys for set and finish it up. Yeah, and then Brandon's going to be like, hey, other teacher, can you call me for set so I don't have to come in for Mr. Wade's set? You wouldn't do that, would you, Brayden?
Possibly.
Possibly. Brayden, you're killing me, Brayden. You're killing me. Your whole body hurts. My ears hurt from all the complaining that they have to endure. My eyes hurt from watching you guys fall asleep when I'm trying to help you prepare for this test. My heart hurts. Okay. Let me see here. Can we... Okay. So what I'm going to do is I will call you guys in for set tomorrow, okay, so we can finish this up, okay? We will stop there. But I'm going to go through these two. I will tonight, okay, I'm going to finish recording this tonight, and I'll do the answers to this, okay? So you guys, if you want to check them, you can check tonight, okay? So keep that in mind. All right, but we'll stop there. Your homework tonight is to study. Okay, folks, I'm going to finish up this video here so that way you can have the rest of this explained for this evening. All right. This is me recording at the end after everyone's left. So, last little bit here, we look at the very back page. So if given solutions, okay, that means if you have the solutions to a quadratic equation, you can use those solutions to help you find the actual original problem. Okay? So, here's how we're going to do that. Given the roots of an equation are negative 8 and negative 3. Okay? So in other words, these are the answers to our quadratic equation. Well, so that means like x equals negative 8 and x equals negative 3, right? Those are our answers. Well, just think about going in reverse. We would then add 8 to both sides here. We get x plus 8 equals 0. There's one of our factors. Add 3 to both sides. Okay. And we get x plus 3 equals 0. And there's the other factor. So we're going to take these two factors, put them together. Okay. And then we will multiply. Okay, FOIL it out. Terms, and there's a quadratic. There's a quadratic that has these as solutions. We're kind of assuming here that we have an x value of 1. Okay. And so an a value of 1 there. And so an a value of 1 there. What we're going to do is we are going to hang on a second. Let's see here. Hang on a second. One second. If you want to wait on, or you can go talk to me. I can meet you up there or something like that too. It's your choice. It's up to you. I'm just going to finish this up. It's up to you. It's fine. I'm just going to finish this up. Yeah, sure, it's fine. So, all right, we can multiply these back together, and that's how we can get our solution. Or get the original problem from the solution. All right, so let's do another one here. The roots we're told for quadratic function. For a quadratic function. We have negative 2 and negative 8 are our solutions, right? That's our answer.
right? X equals -2,
That's
X
our
equals -8.
answer.
So we'll kind of like
right?
work backwards
X
here.
equals
We'll
-2, X
add
equals
2 to both
-8.
sides.
So we'll kind of like
And we
work
get
backwards
X
here. We'll
plus
add
2
2 to both
equals 0,
sides.
so there's our
and we get
factor.
X
So
plus
X plus
2
2
equals 0. So
Right,
there's
same
our
thing here, we'll
factor.
add
So
8
X
to both
plus 2.
sides.
Right? Same
And
thing here.
so
We'll
we
add
get
8
X
to both
plus
sides.
8 equals
And
0.
so we get X
And so
plus
the
8
there, just like
equals
that.
0. And so the
Okay.
plus 8 there, just like
And so
that.
then we can multiply those back together
Okay.
if we want to get the function.
And so then we can
into
multiply those
standard
back together
form,
if we
right?
want
Just FOIL it
to
out.
get the
So
function
X plus
into
2
standard form,
times
right?
X
Just
plus
FOIL it
8.
out.
Now again,
So
we're kind of
X plus
assuming here that
2
A is 1.
times X plus 8. Now again, we're kind of assuming here that A is 1.
So that's what we're going to do. All right, so
that's what's
X
written
times
here.
X,
So that's what we're going
X
to do.
squared,
All
X
right, so
times 8,
X times
X,
X,
2
X
times
squared,
X,
X times
2X, 2 times 8,
2 times
16,
X,
X
2X
squared plus
2
10,
times
X
8
plus
16
is
X squared
a
plus
quadratic
10
that will have
X
those
plus
solutions.
16
Okay, what is the degree? The
a
degree
quadratic
is
that will have
2,
those solutions.
the highest power right
Okay.
there.
What is the degree? The degree is
Okay.
2. It's the highest
We're going to
power
graph
right
this.
there.
Again, we can go to our graphing calculators
Okay.
to do that.
We're going to graph this. Again, we can go to our graphing calculators to do that.
I
Where did
don't.
I put my
There, on my
graphing
calculator.
All right. I don't.
So,
There, on my
let's
seat.
see here.
All right.
X squared plus 2
So
10x
let's see here.
plus 16.
X squared
okay?
plus
Of course, we
2
could also use
10x
another calculation here. But I'll
plus
go ahead and
16,
use. I'll go ahead and
okay?
finish with the
Of
graphing
course, we
calculator
could
here
also
first.
use another calculation here. I'll go ahead and
let's see.
I'll go ahead and finish with the graphing calculator here first. Let's see.
Okay.
Oof.
Goodness gracious.
Okay.
Did I even? Okay.
Goodness gracious.
To negative 8.
Okay.
five,
It's
six,
negative 2.
So I'm going to plot the zeros here.
Negative 8. 1, 2, 3, 4, 5, 6, 7, 8.
That
So I'm going to plot the
seems
zeros
really-
here.
I must have typed this in incorrectly. There it is. Plus 10x.
That seems really.
There we go.
I must have typed this in incorrectly.
typed it in
X squared. There
incorrectly.
it is. Plus 10x.
Okay.
There we go.
So, let's see here.
typed it in
Vertex,
incorrectly.
we can use x
Okay.
equals negative b over 2a.
So, let's see here. Our
Okay, find the
vertex,
vertex,
we
or,
can use x
we
equals
can also
negative
just go to our
b
graphing
over
calculator
2a.
and
Okay, to find the vertex,
second
or we can also
trace
just go to our graphing calculator.
minimum. We'll go to the left.
And second trace
Go to the right.
minimum. We'll go to the
and
left.
then down for the guess there. So it's going to be negative 5, negative
go
9.
To the right. And then down for the guess there.
Okay,
So it's going to be negative 5, negative 9.
5, negative 9. Pick some x values earlier, so like negative 4, negative 3. Negative 5,
No, sorry.
negative 9. Lower
Pick
x
some
values
x
and make
values
this
earlier,
pick
so
some
like
negative
negative 4,
7,
negative 3.
and then negative 5 and negative 3.
No, sorry.
Okay, for the
lower
actual
x values.
one
And
there.
then we go to our
6
table,
and
negative
just fill in the
7,
table here.
and then negative 5 and negative 3.
Negative 5.
Okay, for the after ones there. And then we go to our
negative
table and just fill in the table here.
4,
from the
negative
table.
8,
So,
negative 3, negative 5.
Negative
Okay.
5.
Plot the point.
Negative 8.
Negative 1, 2, 3, 4,
Negative
5,
4,
1,
negative
2,
8,
3,
negative
4,
3,
5,
negative
6,
5. Okay.
7, 8, 9,
Plot the
right
points.
down there.
Negative 1, 2,
Alright,
3, 4,
negative
5.
6,
1,
negative
2,
8.
3, 4, 5, 6,
Oops, sorry,
7,
that goes
8,
right
9.
there,
Right
I think,
down
actually,
there.
right there.
All right.
we
Negative
just
6,
connect the
negative
dots.
8.
Negative 3, negative 1,
Oops, sorry,
2,
that goes
3, 4,
there, I think,
5,
actually. And right there.
Okay.
Okay, and we just can connect the dots then. Negative 3, negative 1, 2, 3, 4, 5.
There it is. Okay.
Okay.
So we found the vertex right. It was negative 5, negative 9. I used the graphing calculator. You could also use the
Yeah,
negative b over 2
there it is.
right
Okay.
there.
So we found the
It'll
vertex
be
right. It was negative
negative
5,
10
negative 9.
over 2
I used the
times
graphing calculator.
1.
You could also
And so
use
that
the
would be
negative
then
b over
negative
2a.
5. There's
Right
your
there.
x coordinate, and
So
you can
it'll
plug it
be
back in. to find the
negative
y coordinate.
10 over 2 times 1.
Last step here, we're going to complete the
And
square.
So that would be then
All right.
negative 5.
So
And
for
there's your
complete
x
square, when we
coordinate,
solve
and you can
this,
plug it
we
back in to
have
find the actual
to,
coordinate.
get our
Right.
x terms
Last
on one
step
side
here,
and
we're
all the
gonna complete
numbers
the
on the other
square.
side. So we start
Right.
by adding 9
So
to
for
both
complete
sides.
square, right, when we
Okay.
solve this,
And
we
then we're
have
looking
to,
for this missing term here
Get
to
our
make
x
this thing
terms on
factor
one
be a
side
perfect
and all the
square,
numbers to the
right?
other
We're gonna
sides.
take
We start by
half the
adding
b
9 to both
term,
sides. Okay? And then we're looking for this missing
and then
term here to
squared,
make this thing factor
and
to be a
that's what we're going
perfect
to add
square.
in here. So
Right?
half
Remember, you
10
take
is
half
5,
the b
squared would be
term.
25. So we add 25, add, oops. sorry,
Okay,
not
and then
plus 25
squared.
there. Okay,
And
so
that's
there
what
it
we're
is.
gonna add in
This
here. So
factors
half of
2x
10
plus
is
5
5
squared,
would
add
be
5 plus x
25.
plus
So
5.
add 25.
That has to be 34.
Add
Square root
oops,
both
sorry,
sides.
plus 25 there.
Okay,
And so
you get
there
x
it
plus
is.
5
This
equals plus
factors
minus
to
root
x plus
34.
5 squared, or x plus
All
5
right.
times x plus 5.
There are no
That
perfect
adds to be
squares.
34.
Sorry,
Square root
34
both
is not a perfect
sides.
square, so it doesn't simplify nicely.
Okay,
And we
so you
can't
get
divide
x
it by
plus
any
5
perfect
equals plus or
squares,
minus
so we'll
root
just leave it the
34.
way it is.
All right.
Subtract the
There are
5
no
over.
perfect
so you get
squares.
5 plus root 34.
34 is not
and
a
then
perfect
you also
square,
have
so it
minus.
doesn't
You go
simplify
again, plus or
nicely.
minus.
And we can't
So you
divide
get
it by any
two
perfect
squares.
squares, so we'll just leave it the way it
All right.
is.
And then here for
Subtract
completing
the 5
square,
over.
same thing. We'll
So you get
add
negative 5
11
plus root
over.
34. And then you also
Okay,
have
x
minus 2
squared
because again, it's
plus
plus or
6x
minus there.
equals
So here are
11.
2 solutions.
Okay, I'm going to do this
All
one
right.
a little bit differently than
And
we
then
did
here for completing the
there,
square,
but
same
we'll-
thing.
oops.
We'll add the 11 over.
Um,
Okay, x squared
all right,
plus
so again, we're looking for 2
6x
numbers,
equals 11.
right? That'll
Okay.
add to make 6.
I'm
We
gonna do
can do
this
the
one a little
same
bit
thing.
differently
This
than what we
becomes a
did
perfect
just
square.
there,
That's going to be
but
our
we'll
3
put
and our
stuff
3
in
there. And then what's missing up here? Well,
all right, so again, we're looking for
x
two
squared,
numbers,
right? There's the x and the x,
right?
make x squared.
That'll
3x
add to
another
make
3x
6, and they
makes
do the
6x.
same thing, so this becomes a perfect
9.
square. So that's going to be our 3
Add 9
and
there,
our
so we
3
get
there.
20 here.
And then what's missing up here?
X
Well,
plus 3
we
squared
have
equals
x squared, right?
20.
There's the x and the x make x
Square
squared.
root
3x, another 3x makes the 6x.
X plus 3
3 times 3
equals
is
the square root of
9.
20.
We'll add 9 there, so we get 20 here.
Okay, don't forget the plus or minus
X
though,
plus
because we
3
are
squared
solving an
equals
equation
20.
here.
Square
Subtract 3
root
on both sides.
x plus
X
3
equals
equals
negative
the
3
square root
plus
of
or minus the
20.
square root of 20. We should really simplify that root 20
Okay,
because we
don't forget the
can.
plus or
Okay,
minus
20 is
though,
not a
because we
perfect
are
square,
solving an
but
equation
root 20
here.
is
Subtract
square
3
root
on
of 4
both
times the square root of
sides.
5.
X
plus
equals
the
negative
2 root
3
of 5.
plus or minus the square root of
So we get
20.
negative 3
We should really
plus or
simplify
minus
that root
2
20
square
because we
root of
can. Okay, 20 is not a perfect square, but root
Okay.
20 is square root of 4 times the square root of 5, which multiplies to 2.
And we'll do one more here, this last
So we
one.
get
Okay,
negative
again,
3
it's not
plus
quite
or
in the right
minus
form.
2
We need to get
square
all the
root
x terms on one side, so I'll subtract that 10 over.
Okay.
Okay. Same thing. I want to factor this thing.
And we'll do one more
I know I
here.
need an
This
x
last
and an
one.
x there
Okay,
to make
again,
the
it's
x
not quite in
squared.
the right form.
And
We
then
need to get
again,
all the x
these
terms
two
on one
numbers are
side,
going to
so I'll
add to make
subtract
negative
that
8.
10
They're going to
over.
multiply to this number. We don't know it
Okay.
yet, though, right? So I'm just going to say
Same
what
thing.
two
I
numbers
wanna factor
are the
this
same.
thing.
We'll add to make negative 8. It's negative 4.
I know I need an
negative
x and
4.
an x there to make the x
Okay.
squared.
And
And
then
then again, I
means
need
negative 4
these
times
two
negative 4,
numbers
we
are going
have
to add to
in
make negative
16
8.
there.
They're going to multiply to this
Complete
number.
that
We don't know it
square.
yet, though,
Okay,
right?
so
So I'm
then
just going to
those will
say
make
what
us
two numbers that are the same
So we have x
will add to make negative 8.
minus
It's
4
negative 4
squared equals
negative 4.
6. Square root now.
And then that means negative 4
Plus
times
or
negative 4.
minus
We have
root
to add in
6.
16
6
there.
is not a perfect
Complete
square.
that square. And
Okay,
so
and it
those
doesn't
will
divide
make
by any
us
perfect squares, so we
6.
just leave it that way.
So we have
We'll
x
add
minus
4 to
4
both sides.
squared equals 6.
I get x equals
square
4
root now.
plus or minus the square root of 6.
Plus or minus root
And
6.
that's our answer.
6 is not a perfect square. Okay, and it doesn't divide by any perfect squares, so we just leave it that way. We'll add 4 to both sides. I get x equals 4 plus or minus the square root of 6. And that's our answer. If you need more help, review this video or ask Mr. Wid to call you in for set.